I'm Olivier Ezratty. I've got many occupations. The main one is I'm a co-founder of the Quantum Energy Initiative, which is an academic and industry group working on the energetics of quantum technologies. The other is I'm a teacher, an academic, a freelance researcher. I'm the author of a very large book of 1,500 pages on quantum technologies, which is open source. I think that quantum engineering is an emerging discipline in the quantum technology space. We need probably to define what is this discipline on top of quantum science and even quantum technologies. Engineering is a very fuzzy domain. There's not a clear definition. There was a military definition in the past that was based on how you build weapons. Nowadays, it's a kind of a discipline that's based on science, on knowledge, which helps people craft solutions and products and technologies that are used by real people. But the real people can be either a company like is using in the future a quantum computer, but it can be also a physicist himself or herself who is doing an experiment and needs a laser, needs some experimental devices which are built with engineering. So in a word, engineering is about also solving problems which are different in nature than what scientists do. Scientists, they extend the reach of knowledge, they test knowledge, they test theories, they try to find lower bounds, for example, limits of the laws of physics, for example. Engineering is about creating solutions based on various constraints. So the constraints can be the science itself, it can be the user need, it can be the economics as well. So engineering is a different discipline where you have a multiple, I would say, influx of constraints and knowledge. But still, engineering is based on science, like mathematics, operational research, quantum physics in the case of quantum technologies. So it's good to have some event to address that question. We are in the middle of the road right now with quantum technologies. The wording quantum technologies is relatively recent. I think it's about 2 decades old. And we heard about 20 years ago about the second quantum revolution. We have quantum communication, quantum sensing, quantum computing. And so progressively, we are getting out of the scientific field and down to the engineering field where we create solutions for end users. But it takes time. And the particularity of quantum science and technology is that science is evolving in parallel with the engineering and with the products. There's a lack of maturity in some situations. There's better maturity in other situations, like with quantum sensing, for example, where the maturity seems a bit better. And quantum computing is a weird beast because we already have computers available. We can use them on the cloud, but we are not there yet with delivering a so-called quantum advantage, where we are way better than classical systems. So it's still in the making. The technology evolution is a mix of scientific progress and engineering progress. And the reason why engineering plays a key role in building a quantum computer is that you need to assemble a lot of disciplines and a lot of scientific disciplines. So the most obvious ones is quantum physics, you have quantum thermodynamics, you've got the electronics, cryogenics, of course quantum information science about algorithms, about how do you build a circuit, how do you build a compiler, how do you build all the software tools to create the solution. So as the product gets more mature, you need to assemble more components to build a complicated system. And this is a new discipline to assemble those systems under constraint. At some point, there's going to be a question to, can you make it affordable, for example, to create a large enough market that would justify all the investments we pour into that domain right now. It's going to be an evolution. We're going to have to build the discipline progressively in various domains like sensing, computing, and communication. Probably it's about extending the reach of the scientific domain to have more engineers getting involved in quantum technologies, more people having multiple skills. So typically, quantum people from the physics space, people who develop software who have a dual skill, like a skill on the quantum circuit design, but also classical software development skills. You need people who have skills in their domain, like chemical simulation or optimization in logistics or whatever domain. So we probably will need more people who have multiple set of skills and create more interdisciplinary teams who can work on designing complex systems. But actually, those organizations, they already exist. These are the startups. Because the startups are very different from the academic labs. Usually, the academic labs who do science and research, they are relatively small teams, very specialized on a specific domain. When in startups, or even large companies like IBM and Google and others, you have larger teams with a larger number of different set of skills. And these are doing engineering by design, because they need to create a product, they need to deliver something, they have a roadmap to follow. So they need to assemble multiple skills in an organization. So it becomes an engineering organization on top of being a sales and marketing organization when they want to sell that. But in between science and business, there's engineering to create the product. To build those systems, you need, again, more science. Because the limits of knowledge is endless. I mean, you never discover everything. So, for example, when we will grow the size of the quantum computer, we may discover new physics phenomenon that the existing laws of physics may not explain entirely. So we need to revisit some parts of quantum science and some laws. The best example is the noise in the qubits. We know that qubits are imperfect. They are victims of noise, environmental noise or their own noise. And fixing the noise is one of the biggest problems in science. And when we will scale the number of physical qubits in a quantum computer with more qubits in a larger system, we will probably discover new shapes and forms of noise. And this will push the scientists to develop new mathematical models, new error correction codes, and probably even new understanding of how light and matter interact at a large scale. And one of the big questions, which is a scientific question, is what is the limit between the quantum world and the classical world? We don't know exactly. The limit is a bit fuzzy. So as we grow the number of physical qubits in a quantum system, we will see how far we can go. Is it 1,000 qubits? Is it 1 million, 1 billion? Maybe at some point we will reach the limit of the quantum world and become classical, where there's no coherence, no superposition, and no entanglement anymore. So in a world, engineering is driving the ecosystem to build systems that will test the limits of our knowledge of quantum physics. So there's going to be a circling back on the physics and on science, I think, at some point. Well, one of the most amazing guy, I think, in the history for me is John von Neumann. It's not the most known. I mean, you have Heisenberg, Schrödinger, and others, but von Neumann is amazing because this is a guy who did many things. And I like the so-called polymath syndrome. So von Neumann initially was instrumental in creating the basics of quantum physics, particularly on the theory of measurement. So it was in the late 20s and early 30s. That's one thing. Then he developed a mathematical tool to simulate the explosive in the atomic bomb. Okay, that's a weapon, okay? But then, just after the war, he discovered and he created the basic principles of how computer is working, with a memory, a logical unit, addressing the data, addressing the code. All that, which is called the Princeton model, is still used today in all computers. And he designed this model between 45 and 49. For me, that's amazing to have somebody who has a contribution in a weapon, basics in quantum science, and basic in information science, all together. This is a particular extreme case. I like also Paul Dirac. He was very introverted, but he did a lot of interesting things. But these are people who died a long time ago. Yeah, John von Neumann, he died at 54, very young. Nowadays, I meet many scientists every day, so I can't name one particularly, but the living folks in that space are amazing as well. It's difficult to rate how they will impact the world. You got to wait a little bit. I'm not a physicist, so I'm an engineer. I was in different fields in the digital economy before. And I have never, ever met so many bright people than in this field. I can rate a small country, Slovenia. It's very rare. I mean, talking about Slovenia is rare. I visited them a year ago, and I thought, okay, it's a small country, I don't know, 2.5 million people. But I discovered the excellence of some scientists there. I remember a guy named Dragan Mihailovic. This guy was designing tools to simulate the way electrons behave in superconducting materials. And he was working with Google. I was amazed by that. He was in his own lab at so-called Joseph Stefan Institute, GSI. And I was surprised to find so bright people in such a small country working with Google. So that amazed me for a small country. But then I met people in Finland, in Denmark. I was in Niels Bohr near office in his building. I met people in the US, of course. I went in Israel, I went in Taiwan, I went in Slovakia recently as well. In Austria, I met Rainer Blatt, who is a key scientist in the history of trapped ions. I had the chance in 24 to meet in a conference 37 Nobel laureates. It's called the Lindau Nobel laureate meetings, I think. And I had a panel discussion with two of them, so Serge Haroche from France and Bill Phillips from the US. So I've met so many bright people, it's amazing. So yeah, I met a guy recently who amazed me. He's another Nobel laureate. His name is Hans von Klitzing. It's not a household name, but still interesting. He discovered the quantum Hall effect in 80, and he got his Nobel Prize in 85, 40 years ago. I met him in Göttingen, the city where quantum physics started a century ago. And we had a nice discussion. I found that his presentation was excellent. He amazed me. He really amazed me. Yeah. Quantum technology and quantum physics have the particularity to acquire a broad set of skills. It's where you have a lot of talent from different parts of the world and different disciplines. And even though there is a lot of uncertainty on the advent of scalable quantum computers or whatever, there's so much energy put in there, so much intelligence, so much talent, that I think whatever happens, something good will come out of this.